Okay, hi. Welcome to our SQL user group. I am standing in for Jimmy. He's currently out of town at work, so we'll make this a little bit more brief. So I want to thank Addison for bringing in food and helping pretty much with everything that requires a monetary help. If you have a couple minutes, any jobs or anything that you have open?
Sure. I'll one specific job here. We've talked to a lot of people before, but there are some new faces, so I'm excited to see new faces. But yes, we do have development opportunities. We do have some DBA opportunities out there right now, both contracts and direct hire. If you'd like some more information, I'd be happy to talk to you about it. Do what I could to help someone either find a job or maybe take the next step in their career.
Well, thank you.
Thank you, guys.
It's food. You have to be happy about food. So. Also, want to say thanks to StarSpace. Through Techlahoma, we're getting this area for free. So we don't make any money off of this. Even when we run the SQL Saturday, we don't take any income from this. It's entirely donation-based. So we appreciate all the contribution that we get from everywhere. There's one SQL Saturday close by coming up that I'm familiar with, and that's in March, and that's in Colorado. So close by is a little bit more abstract, I guess. But that's pretty much the next one that I see coming up. We missed ours last year, and we will have one this coming year for sure. And it will be in the 3rd to 4th week of August, like it normally is, if that helps anyone make any plans for it. We are going to have our next meeting. It's going to be a lightning talk in November, and it is going to be entirely run by people in our own community. So if anyone wants to have a presentation, 5-10 minutes, we're gonna have to start volunteering people, I'm pretty sure. Anything that you have that you've worked on even for a little while, something that you just became aware of, even if it's something that whenever you looked online and you saw 400 posts on it, someone else had to look that up too. So anything that you have, 5-minute presentation, 10, 15-minute presentation, nothing has to be a deep dive. It can be just something along the lines of, here's how I set up my SSMS because it makes me happy and I can see my line numbers, and that's what we need in life is line numbers. And just anything can be useful to someone, and it's always good for a lightning talk. We'll have enough other presentations that will be fine. Just get with us. It'll be on Meetup, I believe, is what we're using right now to coordinate all of that. Feel free to join in. We're volunteering Matt, who used to be our old president. I think he's aware of that. If he's not, he is now, will be soon. And I think that is it for upcoming events. In December, we will have a meeting, but it will most likely be something along the lines of trying to see if we can get any prizes together, ugly t-shirt thing, you know, your normal what you expect to do during holidays. Cookies will be involved. I will find cookies somewhere. I think that covers it for the end of the year. So I want to thank and go ahead and present Brad Fair. He's doing a presentation on solving complex problems, and I'm gonna let him have it.
Thank you. Oh, too kind. There's always that one person clapping. Normally I say, thanks, Mom, but she's not here. So I am not used to having a mic in my face. Normally they clip on, something like that. But I understand that this is how Twitch hears me. Is that right? So if Twitch needs to raise their hand saying they can't hear me, then I suppose that'll work. I'm Brad. I work with Interworks with Bill and Jimmy. I have this presentation on solving complex problems that I decided to share with people because I learned about graph theory and its practical applications some time ago, totally by accident, and then got intrigued enough by it that I just dedicated far too much time talking about it and thinking about it and using it to help me with whatever problems I have. How many of you have heard of graph theory? How many of you know anything about it besides having heard it? Any CS majors in here that actually know graph algorithms? No? All right, well, that dropped off pretty quickly. I got one. Cool. So my experience with graph theory, I was telling a few folks this at lunch today. Are you able to hear me okay? Is that what you're testing? Awesome. What's that?
The air conditioner's probably taking over.
Yeah, that'll happen, won't it? We're good though? Awesome. So yeah, I'd first heard about graph theory kind of by accident. This fellow I was working with in San Francisco he created some weird database design, and I asked him what the values meant in this particular column, and he's like, is that the source node? Is that the destination node, or is that the edge? I'm like, I don't know what you're talking about. This doesn't make any sense. But he flabbergasted me because he gave me unfettered access to his database, SA level access to his database, which is kind of a don't do that please, right? So I asked him if he could get me maybe a different account, and he just created a replica for me in 5 seconds. No big deal. Okay, that'll work. I need to put a view on here. Is this a read-only replica like I thought it was, or can I create things? He's like, what is a view? And I was blown away. Like, how does he create a replica in 5 seconds and doesn't know what a view is? So I Googled him, and it turns out he got his PhD from Stanford in molecular, I don't know, like biology of some sort. His thesis was on whether a transplant would be accepted or rejected by the host. And then he just took that and built some software. He used the same algorithm, he just changed the words. Instead of transplant and host, it was potential employee and company, and wrote some HR software and ended up selling it to one of the tech titans in Silicon Valley. So I'm like, all right, I got to learn your story. And it turns out it was a graph algorithm, so that's what made me dive deep into it, and I realized that there's no company out there that doesn't, let's say that there are very few tech companies, and probably not any notable one, that doesn't have a graph as part of the core competency of the tech company. If you find one that's notable but does not have a graph, tell me about it, because I have not been able to, so I'll alter my materials and give you credit. So this is what it's going to look like. Hi, we're doing that bit right now. I'm going to talk about the Seven Bridges of Königsberg. Have you heard of that one? Yeah, I got a couple people nodding their heads. So this is a fun one on sort of the genesis of graph theory and how it came to be. I'm actually going to walk you through solving that. So if you've heard about it but couldn't make it yourself, we're going to fix that. You should be able to explain it to your grandma over Thanksgiving. And then I'm going to use the same techniques, the same tools to solve a problem that we have at Interworks, trying to figure out who's the best fit for any given job that we have, any client work. So how do you know when we're going to send Jimmy to wherever we've sent Jimmy to this week? Then an analytical problem, solving how alike are two people. And there are plenty of algorithms for this, but I'm going to talk about one in particular, which was kind of fun. And lastly, we're going to take it tech and introduce you to or reaffirm your positive belief in Neo4j. Have any of you used Neo before? Yeah? It's super easy to get involved with. It didn't take me that long to figure out how to use it, so it's a load of fun. And I think we'll be done. Yeah. So here's the Seven Bridges of Königsberg, which was kind of a mathematical riddle until the 1700s that was unsolved. And the riddle is this: can you take a walk through town, visiting each part of town and crossing each bridge only one time? So if you've heard of this before, you may know the answer. If you haven't, try and figure it out. Raise your hand if the answer is yes. Leave your hand down if the answer is no. It's kind of a binary choice, right? Now you have to participate. So we've got a room full of no's. You cannot do this. Well, Leonhard Euler, and I don't know if that's how you say his first name, it's totally how you say his last name. He thought through this and he's like, I don't think I can solve the problem given what I know from this. So he decided that he would simplify it, maybe make it a little bit easier to understand. Fundamentally, we've only got a few pieces involved, right? I'm going to change the picture on you while you're tracing the bridges out with your fingers. I'm not going to change it too much. So now we're not talking about the Seven Bridges of Königsberg, we're talking about the simplified bridges. We've got rid of all of the pubs, which is a shame, all of the buildings and other streets. We're only concerned about the land masses because we want to touch each one, and the bridges because we want to touch those once and only once, right? So does this make it easier to solve? Getting rid of all of that unnecessary detail? Maybe so. but we could take it a little more simple, a little simpler, to the super simplified bridges of Königsberg. And now we have a graph, for those of you into graph theory. Fundamentally, what we've got here is we've removed the river, totally unimportant except that bridges go over it. The land size, the shape of the land, the pubs, the street, the churches, all gone. Unnecessary color, green and blue, right? Now we're just dealing with these circles and lines, which are nodes and edges, or vertices and arcs. They've got a lot of different names associated with them, right? But these are the tools that we use, that he used, Leonhard Euler, to solve the Seven Bridges of Königsberg. So I'm going to add on to this that those nodes, in our case, are land masses, and the edges are bridges. It makes sense given the problem that we're talking about, but we actually get to use those in other areas later for whatever we want. And you can attach extra data to it, like how many lanes is the bridge? How much network traffic can you push over that at one time? How big is the hard disk on the node? Whatever. We can give it any attribute we want. So now we know about the nodes and edges. Let's talk about solving the Seven Bridges problem, right? So what I'm going to do, if you'd entertain me with this, is I'm going to start on a fictitious piece of land, that node, and with just one bridge, I'm going to talk about how I could use that one bridge and touch it only once, right? Cross it only once. So we could start at that node and use the bridge by leaving that node, leaving that piece of land. That's our only option given one bridge, right? So long as we start there. Or we could end there, right? But we can't start and end there, and we can't traverse it. We can't go through it because we've only got the one bridge and we can only use it the one time. So given a single bridge, this piece of land has to be my starting point or my ending point. I have no other option, right? Does that make sense? That was the fundamental idea that he found, is you can't cross through it. It's either the start or the end. Now, let's add another bridge to that piece of land. We've got a couple options here. We could make this the starting point and the ending point, given two bridges. It can't be one of those but not the other. It must be the start and the end if it's going to be either of them. So I could draw it out, but like start inside the landmass, walk off to the right-hand side of the screen, and like crawl around the screen and go back in the landmass, and there you go. Or you could just pass through it, and that would work too. There are no other options here. So given two bridges, if I start there, I end there, or neither of those things. So what about three bridges? Now I could go like this all night, all the way up to 7 bridges, and we can figure out what's going on. But with 3 bridges, it's pretty easy. Right? We've sort of got our 2-bridge scenario plus 1, and that 1 means that we either have to start there or end there, right? Because if you can pass through, you could just consider you take those 2 bridges, throw them over your shoulder. They don't exist anymore. We've just got the 1 bridge. It's got to be our starting point or our ending point. We can't pass through it. 4 bridges, we could make it our start and end, or we could pass through it twice. We make a plus sign through this. So we're starting to see a pattern, as you do when you start dealing with graphs like this. And the pattern is basically, if I have an odd number of bridges, I should start there, or I should end there, but I can't do anything else with those. So you understand the pattern, you have yourself a good time. This is my fellow ginger, Leonhard Euler. This is what he figured out with the 7 bridges. If you have an odd number of bridges, you got to start or end on a single landmass. If you have an even number of bridges given a landmass, you can start and end there or pass through it. So he simplified this even more and came to the conclusion that an Euler path is what they call this, where you touch each bridge once and only once, while also touching every landmass. If a landmass has, well, I'll introduce a couple other terms here. If a landmass has an odd number of bridges coming in, like 1, you'd say it has a degree of 1. If it has an even number of bridges, like 2, you'd say it have a degree of 2, and so on. An Euler path exists only if you have 0 nodes or 2 nodes with odd degrees. That's it. So 2 of your pieces of land can have an odd number of bridges coming out, and the problem is solvable. Or 0 of them could have an odd number of bridges coming out, and the problem is solvable. But if you have 1 of them with an odd number, what do you have to do? You have to start there or end there. But only one of them has an odd number, so you can't start anywhere else or end anywhere else, right? Based off of what we've learned. So this is how he solved it, and he shot his proofs around for other people to see, and they're like, dude, you're a genius. Everything was good. So yeah, this, back to the super simplified bridges of Königsberg, and this time I am going to draw if I can. Can't figure out how to draw. Shame. Well, let's count these then. We have on the left-hand side, that node has a degree of 5, so that's an odd number. Up at the top, we have a degree of 3, so that's an odd number. If those were the only odd numbers, this would be solvable. But on both of the other nodes, they're also odd numbers, which means that there is no path that exists that would allow me to cross each bridge only once. I'd have to cross another bridge twice, at least. So there's the answer to the problem, and it's easy to solve. They actually have games now on the iPhone or Android, whatever it is you've got, where your job is to, given a picture like this, trace going over every bridge once and only once. So it's basically like find the Euler path, except they wouldn't tell you that's what you're doing. Anyway, if you ever want to get good at those, just count the degrees of the nodes. Start with an odd one if one exists and end with the other one. They don't give you an unsolvable one conveniently, which is nice. So I've already talked about the toolkits, nodes, and nodes can be landmass, can be servers, can be whatever, a person, it could be a user, it could be both of those things at the same time because we're people and users. You can give it as many labels as you want, whatever makes sense. And you can also give it a lot of properties like age, name, email address, whatever. Edges, arcs, relationships. These guys are what connect the nodes together. They define the relationships between one node and another. They can be directed or undirected, and it's kind of an easy one to guess at if you're not familiar with it. They can have the arrow on it or not. It doesn't make any difference. And it's an interesting conversation about what makes directed versus undirected. See, an undirected relationship is actually a special case of 2 directed relationships, one in each direction. So a lot of people will say, well, a directed relationship is actually a special case of an undirected, but it's the opposite of that. It just flows both ways, basically. For most purposes, it kind of doesn't matter. But what I find is that a lot of problems you're trying to solve will actually have directed edges. It makes sense that there's an arrow that points from one thing to the other. These can also contain properties like weights, distance, cost, gas prices. So given these 2 tools, nodes and edges, like Euler, we could use these to solve a number of problems. And what I've figured out, and I'd love to be stumped on this if you disagree with me, is that if you can properly define, don't want anyone feeling uncomfortable sitting next to an unclaimed phone case. If you can properly define your problem and solve it in your head, you should be able to map out your process and solve it using this. And I'm not saying it's going to be the most efficient way of solving your problem, but if you can actually solve your problem using your mind, you should be able to solve it using this as a modeling tool. But that's the distinction. You're modeling your problem to solve it. It's not like this is giving you anything extra except a way to clearly think through it. So I have a few examples of notable companies that use graphs as their core competency. Cisco and their networking. It's also called a network graph, so I'm not going to talk too much about Cisco and how they did it. Amazon, do you know what Amazon's graph is? Well, they have a handful now, but their biggest differentiator when Amazon got started. What was it? Do you know? What's that? Recommendation engine, distribution was their big win. So mapping out where they can have things to keep shipping prices low, but also recommendations, which is Google's win, really, recommendations. You type in a search term, they're gonna recommend the most relevant page. So that's a graph. PageRank is a graph algorithm. It's basically, there are a couple ways to think about it. If you wanted to look at it like any random monkey going to any random page on the internet, what's the likelihood that given any random monkey on any random page, clicking any random link, they're going to end up on a specific page? When you sort of total the scores of how frequently random monkeys click on random links and end up on specific pages, you'll get a page rank. The other way of thinking of it is if any web page happened to be like a water source, and all of the links to other pages were pipes connected to the water source, you would be looking for the most relevant page is the one that sort of has the most water flowing into it from other sources. And you'd also get page rank there. So if you ever want to compare plumbing and random monkeys, there's your example. I can't help but think that's a small intersection. Facebook and the social graph, we know it's been talked about at length. What about PayPal? What was their deal? You remember? Fraud detection. Yeah. So for fraud detection, for every purchase that I make, there's some metadata they get, right? What card I purchased with, whether I typed in my verification code or not, what the shipping address is, maybe, I don't know, maybe they get it, maybe they don't, depending on what their role is in the transaction. Certainly what the billing address is, what the name is on the card and how it matches. And so if I purchased, this is very much like me, an algorithms book through Amazon Kindle, right? And then I went and purchased, I don't know, like Embedded C for robotics, again on Amazon Kindle. And then I purchased a blow-up air mattress on, I don't know, wish.com. They're gonna flag me, right? Because this is not a thing that I do. Chase actually did this with me this morning. I have a Chase card, and I'm very much not a purchaser of children's items, but my wife is. And so she just bought a bunch of things from the childrensplace.com for Christmas presents because she's on top of that. And it flagged it as fraudulent for exactly the same reason, right? I just got done buying a bunch of books and now pants on Children's Place. So yeah, it flagged it, but that was PayPal's deal. And that's actually how come they became well known, is they added a level of comfort with people because of this sort of quick detection. So as I said, those are well-known tech companies. If you can think of one where graph is not the core competency, tell me. I don't know of one. So now I promised I would solve a couple different problems with it. We're going to solve an operational problem. Who is the best fit for this job? So recruiter, this will work for you. We have a lot of consultants at Interworks. Those consultants have many skills and specialties. We have a lot of engagements at Interworks, a lot of clients at Interworks, and scheduling is crazy. So the faster we grow, the more people we have, the more skills, the more clients, the more jobs, the harder this problem becomes, right? It's like everybody hugging everybody else every time someone walks into your family's Thanksgiving dinner. Because the more people walk in, the more hugs have to go around. It's a pain in the neck. So I thought there's probably some way of solving this, so I started to model it out. I need to change this to Bill instead of John. John knows SQL. Never mind. Bill knows SQL. I'm going to change it to Jimmy. Bill knows SQL. So now a client calls us and they want SQL work done. Like, I've got two choices. How do I pick from one of these two? Maybe whoever's better, right? So now let's give them relative ranks. Sorry, Bill. John knows SQL at a level 7, whatever that means, and Bill at a level 3, which is obviously less than half as skilled as John is. So now the question is, who should we send? Do you have an answer? I think people would say we should send John. John's better, but maybe it's not a fit. Bill's got web dev chops, and actually at a level 8, whatever that means. And maybe this client needs that in line with the SQL. SQL stuff is basic select statements. Like a level 3, you got that. But web dev, maybe not so much. Angular plus backend stuff and all of that. So encoding all of these skills and sort of figuring out what's required seems like a good idea. So when I draw this on a whiteboard, I do it in the specific details. Why not? But you can abstract that, so a consultant has a skill at a particular level. And we could talk about levels in a bit, because if you self-rank, you're going to have a problem. And if other people rank you, you're going to have a problem. So best I can tell, PageRank is actually a good one for that too. But this is kind of what I was thinking when I was modeling this out, is we have consultants with specific skills and clients that need those specific skills, each at a certain level. This is how I'll solve it, right? It was basically figure out where the skills are the closest match. Then I realized actually that clients will have multiple jobs, and it's never the client that needs the skill, it's actually the work, the job that needs the skill. So the best thing about graphs, you can change your model when you realize that you haven't accounted for everything. So thank goodness for erasers and whiteboards. So yeah, this is kind of what I thought I would do, is I'd have clients that have jobs needing a specific set of skills at a level, and consultants specific set of skills at a level. For what it's worth, I think the concept of client for this conversation is not necessary. So we'll just stick with job. So here our job is SQL work, and we've got Bill and John at a level 3 and a level 7, respectively. So now who would I send? It would obviously be John. Now who would I send? I think it would obviously be Bill, right? At least you get to go somewhere. Now who would I send? It's not quite an off by 1 error. It's right in the middle, which is a conundrum, but I think this is an ideological one, right? Do I send someone to the client that is not quite good enough, actually kind of half as good as they need to be almost? Or do I send someone that is way too good and sort of maybe starve them from another client that might need their level? I don't know. I don't necessarily feel comfortable with either one of these. So I would say if the person is available with a higher skill level, I'll send them. And if the person is not available, then I would probably send the lower skilled person, but make sure we've got backup that's at a higher skill level. So like I would reserve a 9 to help the 5 out of this. But again, it's ideological at that point. So that's what I figured out. And then I don't think I have this modeled. No, I don't have this modeled here. But I built out a graph showing every person we've got at InterWorks that's got technical skills. I left the receptionists and the accounting people out of it. I thought they would appreciate that. And every client that might have some job requiring technical skills. And I sort of married them up and wrote some queries in Neo4j to figure out what was the best match. And I did that sort of by the difference between the skill levels. So as we are here, Bill and John would have shown up as an equal match in this case because we're off by 2. And then I sort of gave a little bit of weight to the one that's above and reduced the weight of the one that's below that so that we could favor the one that's above. Anyway, what I get now is a list of jobs and preferred consultants, but that doesn't necessarily mean I need to send those consultants. So there's another algorithm that I use to actually perform the match after I get the recommendations. And this is the same algorithm that they use in med school to figure out where people do their residencies. If you've heard of it, they actually call it the match, also known as the stable marriage problem. Have you heard of that one? It's not the perfect marriage problem, it's the stable marriage problem. The idea is you want to pair 2 people together who would only choose someone more favorable if they were available, but no one more favorable is available, right? So it's like as good as you can get in that situation, which is really depressing as far as relationships are concerned. But sending consultants, it's not depressing at all. That works quite nicely. So that was an operational issue. We actually have this problem at InterWorks to this day because I haven't implemented this in reusable software. But everyone I talk with that sort of is responsible for people doing projects with specific skills for those projects that appreciate it. But you can use graphs for other things like analytical problems And I wanted to ask the problem of how alike are two people at Interworks. I've been at Interworks 9.5 years, so my priors, my sample problems are Interworks problems. We take a Strengths Finders survey at Interworks. This is supposed to help you identify your top strengths. Have any of you taken this before? Good. Not everyone at Interworks answers that question affirmatively. Yeah, and it is a requirement, but it's a requirement that a lot of people miss out on. So we have this list. It's like 34 different strengths that you can be identified as, and I think anyone would be happy with any of the strengths that come back. So I'm kind of skeptical of things like this. But I will tell you, we have 3 instances at Interworks of people taking this test twice, not one right after another, but years apart. And except for one person, they matched 4 out of 5 between both takes. So whatever it is they're doing, it's not involving random numbers. Here are my 5 in order. Apparently I'm futuristic, very positive, strategery, learner, and competitive. So my questions with this, running through the graph, sort of running through the problem are, if I took the test again, would my results be the same or would they be different? And I haven't taken the test again, but my wife who works at Interworks did. Hers were the same. We had a guy who left from our marketing team to go try out entrepreneurship in Atlanta. 3 years later, came back, took the test again. His results were the same except for one. And then we had one guy that took it while he was an undergrad, like sophomore, I think, in engineering. And then he took it again about a year after he graduated, and his were all different, except maybe one. I don't remember. So 2 of the 3 people I know in our data set that have taken it again were a really good match. I suspect I would be too. So does this make me a good fit for any particular roles at Interworks? I don't know. I was curious to find out. Is there such a thing as a good fit for a particular role anyway? Like, is there some sort of fingerprint of who's a good fit for being a developer, being a DBA, being in the marketing team? I don't know. And then, are former Interworks employees alike in any way? Based off of, for instance, I could group by whether we caused them to no longer be at Interworks, we being Interworks, or whether they were just moving on to greener pastures. So I asked all of those. So here's how I modeled it, right? I have futuristic, positivity, strategic, learner, and competition. And they were ordinal. They were in order, though I don't know to what strength. Like, I don't know if 2 and 3 were really close or if they were actually pretty far away, right? They don't give me a vector. They don't give me some strength to work with. They just tell me which ones are in what order. So going through the 5 questions again, if I took the test again, would my results be different? Now, from a modeling perspective, if I took the test again, what would I do? So I took the test once here. I take the test again and I get something back that's different. How would I represent it on this model? I don't necessarily have a good way to. I'm missing something in my model. The new test, right? So I could sort of say that new number 1 is over there and create, this is known as a hyperedge, in as much as it links 2 things to one thing. Neo4j doesn't support hyperedges, and I've never found a good use for them. Normally, when you find a hyperedge, it's an indicator that you're missing a piece of your model, that you're not thinking through the problem clearly. And anytime anyone has ever tried to rebut that with me, we've determined they were missing a piece of their model. So I'm open to finding a use case for hyperedges if you have one, but I haven't yet. So this is what I decided I would do instead. Actually bring the test in, and these are my test results, and I took the test, so that's how I'd model it. I'm also a solutions architect at Interworks, so I could maybe attach that so I could figure out, you know, if I'm a fit for a particular role. If there's such thing as a good fit anyway, I have enough info to answer this. Like, I could tie solutions architects to each one of these and figure out if there's any particular category that shows up over and over again. And then our former Interworks employees alike in any way. Like, I'd love to predict turnover if I could. So same thing though, instead of solution architect, we could put you're fired, and if we consistently land on one of these, then we just not hire them. I don't know. So simplifying that, we've got a person who has a role, who has taken a test which has exposed different strengths, right? That's the model. And if I'm interested in seeing, for instance, how alike two people are, then we can kind of eyeball one person's test results in another and say, yeah, they're a match, or no, they're not a match. So I'll add test here, which this is not a thing a lot of people are used to when they model. I'm sort of building recursive data. It's cool for forum comments and stuff like that too. But it's something that happens all the time inside of a graph model where you've got a loop in and of itself. So this was actually the full model that I did for answering this sort of analytical question. And then I ran into a problem. I'm a college dropout. I certainly did not major in math. Like, I'm not bad at math, but I'm certainly no expert. So I had to ask for help from friends who are, you know, masters in pure math and then bachelors in applied math and several computer scientists. Like, help me find algorithms, guys. And yeah, and we talked through a couple notes. Hey, none of my presentations would be complete without a pun. Y'all are familiar with Slack, I assume. You know how you can do reactions? There's this GIF of a monkey doing a rim shot on a drum set, rolling his eyes. You familiar with it? So they've taken a screenshot of the monkey's face with eyes mid-roll and added that as a reaction on our Interworks Slack channels. And you invoke that by typing in my name. It's a badge of honor, really. So again, with this test, order matters. Those were ordinal, but we don't understand how much it matters because they don't give us that data back. But also, we don't have everything. There are 34 strengths in Strengths Finders. We only have the top 5. So this was the thing I posited to our math folks. And I said, given that we have only 5 of 34, and that we don't know how strong the ordering is for a particular person, how do we figure out similarity? And there are a couple answers. The Jacquard similarity, if you're familiar with it, is the intersection of the two divided by the union of the two. So if I was a match with somebody on 3 of 5, then the intersection would be 3 and the union would be 10, I believe. So that would be a particular match. I wasn't really convinced that worked, so then I modified that to the intersection and then those that weren't in the intersection as the denominator, right? So it would have been a 3 of 7. Is that right? I don't know. Huh? 3 matched. Yeah, 3 matched. Pretty close, but that wasn't enough. That didn't calculate order mattering. So this is, for instance, John and Bill of previous examples. And congrats, by the way, at having your number 1 strength being C. So yeah, this is the order that they came in, the person, and then the strength itself. And we always got to make things ambiguous and use variables, or math people don't like you. So here are the matches. Only 3 of them match. Only one of them's in the same place across these. So there's a little bit of a strength between them, but other than that, there's some variation. And what I decided to do was we identified an algorithm called a rank biased overlap, which biases the farther left ones higher than the farther right ones. And it's really simple to explain on a whiteboard. It is not simple to explain in an abstract. Conveniently, I have something similar to a whiteboard up on the screen, so I'm just going to walk through how you calculate it. We are given the first entry here, a 0 of 1 of them matching. Given the first 2, we are 1 of 2 of them matching. Given the first 3, we are 2 of 3 of them matching. The first 4, now we are 3 of 4. And as we enter the fifth there, we were 3 of 5 that match. You follow how I did that? Pretty easy. Given the list now, how many match in each iteration. And so then we just add those together. And you can see that first one, if it matched, was actually going to play a part in the first piece, the second piece, the third piece, the fourth piece, the fifth piece. So that's where the rank bias comes from. Like the earlier the match, the more important it becomes. So the second match there actually played a part in all of the subsequent pieces of this. And then we divide it by the list length, and we've got a 50% match, which it's 3 out of 5, so you'd think, well, it's higher than 50%, but we had a dock points because Bill and John don't have the same order of those pieces that matched. So I ran this through, and I'd love to see what this would look like in SQL. I talked with you about this, right? So I ran this through Neo4j and calculated, I think, 7,500 matches in a fraction of a second, which was really cool. I don't think it would be that fast if we use something like Microsoft SQL. I think it would be not that fast. So I'm interested in that, Bill, when we can. So what do we find? Learning is a strength of a lot of people at Interworks, so that's cool. When we find someone that's a learner as part of their strengths, we know that they're kindred spirits. Teams are diverse. I realized that actually very few teams had an attribute that was uniquely theirs. Our sales team, only one person matched one other person on one attribute. All other people and all other attributes were unique, which was really cool. And then this one's obvious in hindsight. You can't predict who's going to leave based off of what they're good at. We never fired anyone at Interworks for being good at something. Doesn't that make sense now? It didn't make, like you wouldn't have told me that until I pointed it out. But we couldn't find any relation at all between people who left of their own accord, people who didn't, and people we still had, because we're calculating their strengths. Now, when Gallup releases Weakness Finder, we'll have another conversation. And these tests do appear to return pretty consistent results. The last one, I think a really cool one, our closest match is about 80%. The cool thing about that was our closest match was the person who founded our BI team. As you can imagine, this old, curmudgeonly, gray-haired, very, very nasty person was almost a perfect match, off by 1, with our receptionist in Oklahoma City. And she was a fraction his age and very, very dissimilar. So it was weird how they were the closest match. But their attributes actually described them, so I think maybe deep down they had something in common. So the question here is, and this is not something I'm solving as part of this presentation, but do you think that maybe we could merge our operations problem here and our strengths problem, such that if we decide Bill at a 3 is a better fit for that SQL job requiring a 5, only because he has learner as his #1 strength, and John at a 7 doesn't? I don't know, maybe. I'm sure you could find something. Would that provide us with more insight? Probably. The way I see it is the more data we can put into a model, maybe the better we can refine it. I'm going to put an asterisk, a verbal asterisk at the end of that one, because overfitting is a problem, right? If you're into data science, you know overfitting is a problem. But I think these details may matter to an extent, and if we can expose that extent, we should use it. If we can't expose that extent, then we should wholeheartedly ignore it. So I've solved those operational analytical problems. Again, these are 2 things which we actually ran through at Interworks. I've solved a number of other issues using graph theory. So I think you could probably identify some and do it yourself, which brings me to Neo4j. We had a couple other people join. Have you guys heard of Neo4j? No? It's a graph database, and it's super easy to work with. So let's talk about Neo4j. I was told that SQL Server's coming out with a graph component. Yeah. Yeah, I don't know what it's going to look like, but I hope they use Cipher for their query language, because it is sweet. It's awesome.
So we want to time test SQL Server versus Neo4j. Can I use 2017?
Yes, but do it with the relational database too. I'm not saying only, because I'd be interested in seeing how well they do. Neo4j is not the only graph database, by the way. There are a lot of them, and Facebook has implemented, and other companies have implemented MySQL or MySQL, depending on what you want to call it, right? They've implemented that and heavily customized it to be their graph database. So when you do a graph search on Facebook, if any of you are still on Facebook, it will hit MySQL. So this was my model for figuring out what consultants know what skills. And Cipher, Neo4j's query language, is just an ASCII art version of this. So I think if I were to ask you to type using only characters this, you would come up with a Cipher query. It would look like this. So we have a couple pieces to this, right? The Cipher representation of a random consultant who may know a particular skill. The parentheses here represent a node. The line and the arrow represents a directed edge. So how would you represent an undirected edge, since we're now Cipher experts? Yeah, take the arrow off. That's it. It's really easy. We have a couple other things. You see that C:consultant? So the :consultant piece is a label. That's how I identify what type of node it is, because it could as easily be a skill, right? It's just a circle, some abstract idea of a thing. So I need to make it not abstract, and we do that with labels. You can stack labels. A consultant could be a user, for instance. So if I put this in a system that anyone could use at Interworks, and I wanted this to also handle authentication, I would probably make that also a user label. So I could do C:consultant:user, and I would get consultants which are also users. That C is an identifier of sorts that lets me use the result as a part of my query, where it's sort of abstract. And then that nose there, let's see here. What would they call that if it were on an edge? I can't remember. I don't think it's not a label. Do you remember what it's called? The nose piece, it's on the edge, so it's not a label. Type. It's a type. Right? Basic words. Yeah, it's a type. So between these, the identifiers, the type, the label, you should be able to do things. So this is what a sample query would look like, and it's very SQL-ish in nature. I'm going to match this particular path. This is what you would call it. This path starts with a consultant, walks across the nose bridge, and ends up at the skill, where k.level is greater than or equal to 5. This is going to get me John, based off of our previous data, right? And s.name, so the skill I'm looking for is Python. So now John's totally out of the mix. He's just a SQL guy. And then I'm going to return the consultant name and what level it is they know, ordering that in descending fashion. I could also figure out which consultants know Python and HTML. Maybe I want them to write a Flask app or something by doing this. I told you that C identifier is something I could use in another place, and so you see me doing that here. I no longer need to specify the consultant label, because what I'm doing is taking the one I've already found and putting them in the second piece of this query. So I'm making it such that they know Python at a level 5 or higher, and they know HTML at a level 7 or higher. So you can imagine my having built a query like this to account for the rank biased overlap, right? I matched the paths that intersected from 2 people on skill 1, and then skills 1 and 2, and summed up how many actually completed a circuit. And that worked out pretty easily. So you could do this with a number of other things, and you can also pass, we're not doing it in this case, you can pass a result from this query into another, much like you would with sort of subqueries in SQL, so that you can chain more complicated rules together. So that is Cipher in a nutshell, and on Neo4j's website they have like this Cipher Academy course that you can go through, and they'll tell you you need to prepare for a couple hours doing this course start to finish. Like, you download Video Speed Controller for Chrome, you knock through it in 15, 20 minutes. It's easy. It's fun. If any of you have any complex problems that you could model, or any problems that you could model using this, I'd be interested to hear about it. Be interested in helping you model that. And I would hope that you could find patterns where some didn't exist. There have been a couple things that I've noticed with regards to modeling these using graphs. At any rate, the last tech section was pretty short because honestly it's pretty easy to get from a conceptual perspective. How to get Neo4j on there, how to query for data, how to put data in. It's exactly as you would think it would work out. Plus, they've got a cheat sheet that you can go look at. It makes it pretty easy. I'm an instructor, a trainer, a teacher, whatever. This week I'm going to go, don't tell anyone, please. I'm going to go guest lecture for a PhD class. None of them know I'm a dropout, so keep that quiet. At any rate, I'm used to assigning homework. So you could go to graphacademy.com, should you want to, I'm not grading you, and run through their, like I said, it'd take you 20 minutes if you could just speed up the videos. Model a problem of yours. There's something called graph gists. You guys know about gists, I assume, on Git. Yeah, GitHub. So graph gists, you put in Cipher, and it will actually compute and allow you to basically work with whatever data set that you've got, which is a great way to model a problem out, collaborate with people. You can edit and revise all the cool things. There are a lot of examples that you can use. So if you were looking at fraud detection, you could find a handful of fraud detection ones at this website. There are also, any of you into Scotch whiskeys? Any other type of whiskeys? Pretty much no? Okay, well, if you were looking for whiskey recommendations, you'll find a whiskey graph. There's also a beer graph if you like beers. And it is October, so Oktoberfest beers will probably be on there. And then, if you're on Twitter, let me know if thinking about things using graphs brings you any new insights. I'd like to think it does. If not, I apologize for having wasted somewhere around 58.5 minutes of your time. Did you have any questions? Yes. So I'm repeating for the fine folks on Twitch or people who look at this later, but I've been asked if it's bad for people to rate themselves on a skill and it's bad for other people to rate you on a skill, sort of what's the synopsis for how I've overcome that? And there are two ways that you could, right? How many of you are on LinkedIn? My realtor, he actually acknowledged that I am an ace when it comes to VMware. Isn't that great? And you can see that endorsement on there and everything, but he's a realtor. I don't even know if he knows what VMware is. So you run into this problem with other people rating you is like, how should you really care? Like if someone comes to me and says, Brad, I think you are a 7 out of 10 on networking. I'm like, well, thank you for that. So let's sit down and talk about spanning tree protocol, pretty please. And they're like, what's spanning tree? Like, you can't rate me as a 7 out of 10. Come on. You're like a realtor rating me on VMware. But on the other hand, if someone rated themselves like a 9 out of 10 and didn't know spanning tree, that would be a problem. So that's both sides of it. And your question is, how do you solve that? Probably the guy with the highest networking rating or switching rating, whatever, would be the right one to rate other people, or at least those people that he rated would probably trend towards his rating because he knows how to do that properly. So there's PageRank all over again. That's the PageRank algorithm, and you could use that. Neo4j has a PageRank built in, so you just feed it the metadata and it will solve. The other way, which I think we're going to do, is you give people the guidelines on how to self-rate, and you make the guidelines inescapable. And this is what we've done at Interworks. So we have 0 through 5. And 0 is whether I know it or not, don't talk with me about it. So basically anyone that has ever worked with SharePoint is 0 on SharePoint. Solid, but yeah, I think that's right. Yeah. And then a 1 is I can't do this. A 2 is I can do this with guidance. A 3 is I can do this without guidance. A 4 is I could guide people on this. And a 5 is I'm the subject matter expert. And so we don't normally have people gunning to be the subject matter experts for a particular piece of technology because it comes with kind of a heavy workload. We do have people that know enough they'd be willing to lend a helping hand. Those guys get 4. We have people that know enough that they should be able to do most things without the helping hand. Those guys get 3. And we found that this kind of encourages people to rate themselves properly, right? Because if they rate themselves as a 2 because they need guidance, then maybe that's remedial and they won't get a good raise this year. If they rate themselves as a 4 and they can't deliver when one of their coworkers get in a bind, then that'll be a problem too. So, like I said, it sort of forces their hand. We've game theoried self-rating. And it works because that's a pretty good scale. So that's how we came through. You're welcome. I didn't come up with that. I stole it wholesale. I mean, no shame. Any other questions? Did you learn anything? Okay. Well, wasn't a waste of your time then. Awesome. Thanks for letting me come up and speak. I get a kick out of this stuff for some weird reason. And I absolutely love graphs. So I appreciate it quite a lot.